you're doing good today. We're moving on to 510 in our Unit 5, which our next 3 lessons, we're going to be dealing with something called trig ratios, okay? And the first one we're going to look at is called the sine trig ratio, okay? So we're going to use this to find some missing sides of a right triangle, and we'll put that into play, okay? So let's jump into it. All right, so what's happening here is basically you're given a right triangle, and inside that right triangle, you're going to be given angle measurements. And we're going to be able to use those angle measurements to find different sides of our right triangle just by using an angle and one side measurement, okay? I'm going to show you guys how to do that. So right now, the sine ratio is known as opposite side length over the hypotenuse. And what I mean by that is whenever we end up taking one of our triangles here, our right triangles, we're going to be looking from either this angle or we're going to be looking from the other angle. Our sides are going to change depending on what angle we are using, okay? So it says with theta being the angle referenced. So that means on this one right now, if I'm doing the sine of A, so I need to find what the sine ratio of A is going to be. So with that being said, automatically I know opposite of my right angle is always your hypotenuse. Always. It's never going to change. And so right now I'm doing the sine of A. So that means whatever angle A is, that's what I'm working from. So opposite of angle A here is going to be my opposite side. And then the third side that I did not label is going to be my adjacent side. So right now, if I'm going to write the sine ratio of A, that's going to be equal to the opposite side over the hypotenuse. So right now in this instance, the opposite side is going to be BC. So whatever the length of BC is going to go on top. And then the hypotenuse is going to be side AC. So AC is going to go on bottom. So we would end up putting the 2 measurements on here, and we're going to end up working some problems here in a little bit to show you how this works, okay? So now on this one, we're going to be finding the sine ratio of angle C. So right now, angle C is down here. So now things are going to change up just a tad bit because we're looking from a different angle. So over here, we're looking from A. Over here now, we're looking from C. So with that being said, opposite of my right angle is always going to be your hypotenuse. That is never going to change, okay? Now, opposite of angle C is going to be my opposite side. And then the third side that I did not label is obviously my adjacent side, okay? And so we're going to be using the adjacent side later. So right now, if I'm going to write the ratio of the sine of C, the opposite side is going to be AB. So AB goes on top. And then the hypotenuse is going to be the same, which is AC. So ladies and gentlemen, that is going to be the sine ratio of sine C right there, okay? So what we're going to do is we're going to take this. You will need a calculator, or you will need the Desmos scientific calculator on your computer, and I'm going to show you guys how this works. So let's jump over to example number 1. All right, guys, so on example number 1 here, it says, what is the value of x? So right now, the one thing you need to recognize is I have a right triangle. Trig ratios can only be used on right triangles. So right now, let's go ahead and look. I've been given angle 29 right now. So that's going to be the angle that I'm going to reference within my sine. So that means I need to do the sine is going to be opposite over hypotenuse. Okay? So in this instance, I'm doing the sine of 29. This is what I'm working from. So the sine of 29, this is going to be my opposite side. Opposite the right angle is always your hypotenuse. And this third side down here is going to be my adjacent side. So with that being said, opposite side is going to be x. So I'm going to put x on top. The hypotenuse here is going to be 13. So ladies and gentlemen, what I'm doing here is if I was to type the sine of 29 in the calculator, it's going to give me a decimal. So I'm trying to find the value of x. If I put that on top, is going to make both of these equal to each other. So basically what I'm trying to do is I'm going to get x by itself. So in order for me to do that, I need to multiply by 13 on both sides. Multiply by 13. So that's going to cancel on this side. So x is going to be equal to, and then literally inside your calculator or on your Desmos calculator, you're going to do 13 times, and then on these calculators, you're going to click the trig button right here by the control button. And then you're going to click sine. And then what's going to happen is you're going to get sine, and then there's going to be some parentheses. And inside those parentheses, you need to click 29, which is going to be your angle measurement. So when you click that enter button, you should get 6.30. Ladies and gentlemen, that is going to be your value of x. Okay? All right, let's jump over to example number 2. All right, so now on example number 2, it's asking me to find the hypotenuse. And so right now, we know I have a right triangle, okay? And if we look at this is 90 and this is 60, that means this angle up here is going to be 30, okay? So if I want to end up using the sine ratio, I'm going to have to be doing everything from angle 30 here, okay? So right now, opposite of the 30 is going to be your opposite side. Opposite the 90 is going to be your hypotenuse always. And then the side that isn't labeled up here is your adjacent side, but we're not worried about that because we're using the sine ratio, okay? So right now, I know that sine is going to be the opposite over the hypotenuse. I don't know why I put hypotenuse, okay? And so now I'm doing the sine of 30 degrees. So I'm going to do the sine of 30 is equal to, and it looks like in this situation, my opposite side is going to be 5. And my hypotenuse, I don't know the hypotenuse. So I'm going to represent that as x. And so right now, ladies and gentlemen, I'm going to show you mathematically how this works here, but I'm going to show you a quick way to do it as well, okay? So right now, if I have x on bottom, I actually have to multiply by x on both sides first. So that's going to cancel. I'm going to be left with x times the sine of 30 is going to be equal to 5. And so now in order to get x by itself right now, I have to divide by the sine of 30 on both sides. So what's going to happen, this is going to cancel. So I'm going to be left with x is equal to, and I have to do 5 divided by the sine of 30. So 5 divided by the sine of 30 is going to end up giving me 10. So x is going to end up giving you 10. So we know in a 30, 60, 90, I do x times 2 to get this, which is 10, okay? But what I want to show you here is whenever you have this variable on bottom over here in your ratio, what happened from here all the way down to here is that literally the x and the sine 30 swap sides. So the sine 30 ended up bottom and the x ended up over here. So they ended up just swapping places. So anytime that you have an x on bottom, just literally take the ratio, the x, and this and flip places. That's all you have to do, okay? All right, moving on. All right, so now looking at example number 3, it says, what is the length of DF? So right now, this is going to be the angle or the side that I'm trying to find. So right now, if we look, I have a right triangle. So that means I could possibly use my trig ratios. So with that being said, I'm given the angle 20 here. So this is going to be the angle that I'm going to reference. So right now, I'm going from angle 20 all the way across the triangle on that opposite side is going to be my opposite side. Opposite the 90-degree angle is always going to be your hypotenuse. And you notice I label this the same way every single time. And then the third side that I did not label is always your adjacent side. So with that being said, I am going to be using my sine ratio because I need my opposite side and I have my hypotenuse. So I'm going to be using the opposite over the hypotenuse. So with that being said, I am doing the sine of 20. My opposite side is going to be x, so I'm putting x on top. And my hypotenuse is on bottom, so I'm going to put 8 as my hypotenuse. So now in order for me to get x by itself over here, I am dividing by 8. So that means I need to multiply by 8 on both sides. So this cancels. So now in my calculator, I'm going to do 8 times the sine of 20. And when I click enter, that should give you 2.73. So ladies and gentlemen, your answer for DF is going to be 2.73. And sometimes it'll ask you to round and do all this other jazz, but I'm just doing it to that place right there, okay? Let's hop over to example number 4. All right, so now on example number 4, it says a 12-foot long ladder is leaning against the wall. It reaches 8 feet up the wall. What angle? So we are trying to find an angle here. This is a key piece of information. I'm going to show you guys how to do it. Does the ladder make with the ground round to the nearest degree? So right now, let's go ahead and draw my picture. So right now I have a ladder. That's my ladder, which is 12 feet long. So I have from the bottom of the ladder to the building of the wall. And then the ladder goes up 8 feet up the wall. So right now, this is going to be the look of my triangle here, okay? So now with that being said, it says, what angle does the ladder make with the ground? So that means I am trying to find this angle right here, okay? And so now I am looking at everything from this angle right here. So if we look here from this angle, this is going to be my opposite side. Opposite the 90 is always your hypotenuse. And then this is going to be my adjacent side. So with that being said, X here, I have my opposite side, I have my hypotenuse. Well, I know that the sine ratio is going to be opposite over hypotenuse. So now with that being said, I am trying to find the sine of X is equal to my opposite side, which is 8, and my hypotenuse, which is 12. So ladies and gentlemen, anytime that you are trying to find what the angle is, so that's what X is right now, we're trying to find the angle, you're going to use something called inverse. So in your calculator or on your computer, this is what it's going to look like. You should see a sign with a -1 symbol up in the exponent area. This is known as inverse. So anytime you're trying to find the angle, you are going to be using the inverse. So you're going to go click that button on your calculator or on your computer, the sign of inverse right here. And then inside those parentheses, you're literally just going to put the ratio. So I'm going to put 8 over 12. And so whenever I type that in the calculator, so I'm going to go to Trig, I'm going to go to sine -1, I'm going to do 8 divided by 12. And when I click enter, my angle comes out to be 41.8 degrees. So ladies and gentlemen, your missing angle, or the angle that the ladder is leaning up on the wall, is going to be 41.8 degrees. So you're going to use this as inverse to end up finding a missing angle, okay? All right, guys, if you guys have any questions, any concerns, please pause that video, ask some questions, let me know. Good luck on your skills.